Lights, camera, fractions!
Oh, nice.
Oh, you.
I like that. I didn't
Thank you for being in this class.
Haven't heard that one before. That's really good. Okay.
Those all mirrors.
So we are going to take a station identification break, right? We're going to basically have a little advertisement or whatever. Like out of algebra, we're going to just suddenly pop into geometry, okay? And we're going to do this on and off throughout this year and next year. It doesn't always fit with the algebra stuff I'm teaching, and that's okay. But this actually sort of does. I mean, it will. You'll see what I mean in a little while.
I know.
But it is there's a lot of terminology in this, and I think if we start now early in the year, then as we talk about it more and more throughout the year, it will become second nature and obvious to you. I think in the past when I've taught this, I find that people just get lost in these words, right? And they don't quite know, they don't remember what they mean. The truth is, every single word there is very logically chosen. I mean, they actually make sense. Sometimes words in math don't make sense, right? But these words actually make sense with what they mean. Okay, so the title is Parallel Lines and Transversals. Okay, so these two lines are parallel. Now, does anybody know how I can denote that they're parallel? How can I show that they're parallel?
Well, first, like, we can, like, if, never mind, right?
So it's just something I can do. I have to do something to each line. I have to write something on each line. Go ahead.
Did you have to do the arrows?
Yes, exactly. I would do arrows. I wouldn't do niches or little ticks. Because that tells you that they are the same size, right? The same length.
Yeah.
So I would have to do this, right? And that tells you that these two lines are parallel. So that's pretty important information, and I should have put it up there, but I didn't, right? So now we know these are parallel lines, these two, and then this line that comes at a diagonal through it, it doesn't always have to be at a diagonal. It could be 90 degrees from this, it could be anything. I could have two transversals, but this is called a transversal line. Now that I don't really know transverse. To transverse, like if you're walking to school, right? And you'd have to go normally, here's you and here's the school, but you have to go this way because the street's that way, and then you have to go that way. Well, you can transverse. You can go diagonally through somebody's field and backyard and front yard, right? It's a very exciting thing to do when you're not supposed to,
What do you
right?
think about it going across the street?
Transversal. I don't even know what transverse.
It means to like change position, if I remember correctly, or like just changing the only thing.
Yeah.
Maybe.
So whatever, but
Trans is
in
to move, like transport.
like transport.
And
Verse is a line.
Verse is to sing while you're walking, right? Right. Okay, whatever. Right? So transversal. That is a transversal line, and sometimes you'll see two. I could have drawn another one like this, or whatever. But for now, we're going to just stick with one. And then we have all these angles. We have this angle, we have this angle, we have this angle, we have this angle, we have this, right? And some of these angles are equal, right? As a matter of fact, I'm going to tell you this right up front. When you have two parallel lines and one transversal, there are only two angles. And this is the abbreviation for angles. It's like a little angle with an S, right? There are only two angles. It looks like there's a lot. There are a lot of them, but half of them are the same angle. And the other half are the same other angle, right? There's only two angles. That's why these are so unbelievably easy. But we have to know what they are in relation to this. Now, first of all, a vertical angle, if you have two straight lines, well, here, I'll do it up here. If I have two straight lines, and you see how you've got this angle here, and it's opposite this angle here, right? Those are called vertical angles. It doesn't mean that they have to be up and down. It just means that they are directly across from each other where two lines intersect, okay? That's the definition of a vertical angle. And that's a weird definition, but that is it, right? And that means these two, this one, and I'm going to put two little arcs so that you can see, those two are vertical angles. Does that make sense? You see that? So vertical angles are awesome because they're easy. Whenever you see two lines, the angles opposite each other are always equal, right? So give me an example of two vertical angles. Okay, Michael. In this.
B and D.
B and D. So we could say B and D. Right? Anybody else? Somebody else. Okay, Anna.
E and G.
E and G, correct. E and G, right?
Or
Mira, another one?
A and C.
A and C, right. So those are really easy, right?
Is that a TV channel?
You forgot
A.
one.
There's a lot.
Oh, no.
There's a lot, right? There's tons. So, well, there's not
Four.
tons. There's some.
There's 8.
I know, Joe.
There's 8, right?
There's 8 angles, but
Right.
there's 4 verticals.
So verticals, you guys get them, right? They're pretty easy. Now we got to talk about alternate interior angles. First of all, what does alternate mean?
It's different, or it's like you can have one thing, or alternatively, you could have another for a cheaper
Correct,
cost.
right? It's sort of like a choice. Are you going to be on this side? Is your choice going to be on this side, or is your choice going to be on this side, right? Which choice? Is it going to be this one or this one? All right. What does interior mean when you have parallel lines? What would you think interior would mean? Inside what? Inside the parallel lines, right? So I have my two parallel lines. This is all the interior, right? Where would be the exterior? All this out here and all this up here, right? That's the exterior. That makes sense, doesn't it?
Yeah.
Right? This is the interior. This is the exterior, exterior, exterior. Okay, so that's awesome. So this says alternate interior angles. So let's think about it. If I had a D, that's this choice. The other choice would be this choice down here. In other words, alternate means I go to the other side of the transversal line and I go down here. And alternate interior angles are equal. Look at that. D is the same as F. And you can tell really easily because it's obvious, right? There's only two angles in this entire thing. This is an acute angle. What do I mean by acute?
Roll it in.
Yes, and this is a
Obtuse.
obtuse angle greater than 90 degrees, right? So you can tell these are acute, that's acute. They have to be the same angle. Alternate interior. Okay, so let's write down alternate interior. Give me an example of an alternate interior. Yes. D and F. All right, alternate interior. D and F. Okay, another one.
HD.
C and E.
C and E. What did you say, London?
HD.
H what?
D.
But that's outside.
Okay, but
Oh.
the H is exterior
Oh.
now, right? Interior means they have to be between the parallel lines. Really, there's only two, right? Two sets, right? You agree with me? In this, when you have a transversal and two parallel lines, it's either D and F or E and C. That's it, right? Okay, so now let's talk about alternate exterior. We already know exterior is
Outside.
outside the parallel lines, right? Now, what do they mean by alternate? Give me an example of what you think would be an alternate exterior. Gideon,
Would be A and G.
bullseye.
Yeah.
Is that what you were going to say? Something like that? Do you guys see that? So, A is on the left side, exterior, up here. G is on the right side, exterior, below the, right? Down below. So A and G would be alternate exterior. A and G. Give me another one.
H and B.
H and B, correct. H and B. Okay, I think that's it, right?
Yeah.
Yes. Okay, now suddenly we have corresponding angles. corresponding. Co-respond. Co means the same, right? The same relationship, right? Correspond. So if this one, there's a lot of these. There's a lot of these on this. And a corresponding angle would be, let's say I look at A. Would you agree with me that A is above
Yeah.
the parallel line, the top parallel line, and it's to the left of the transversal? You agree with me?
Yeah.
So if I go down to the next parallel line, and I do the same thing, I go above that parallel line and to the left of the transversal, A and E are corresponding angles. If I drew a line, this is the one that most people have the hardest time getting. But think about it. If I drew a great circle, lovely paper, lovely pen. Okay, if I drew, now I got to draw it exactly like I did. Okay, if I draw a circle there and I draw a circle here, and I just had, I mean, it looks like the same thing, right? So this, top left, top right, bottom left, bottom right. They're corresponding angles. They respond exactly the same because they have the exact same number, same value, and they're together, right? That makes sense? So A, E, B, F. Okay, so give me, let's write down a few examples. Give me one. Yes.
Well, first off, I'll give you one of those, but A and F.
A and
A and E.
A and E, good.
Anyways, but my question,
Okay.
never mind, I forgot my question.
You know, and I did too. I can't remember it at all. Yes. Say it again.
Oh, I remember my
D, where are we? D and H. Yes, D and H. Good. Awesome. D and H. Okay, another one. Mira?
C and G.
C and G. Correct.
Gary, I remember my question.
C and G. Okay, Gideon, what was your question?
Do the corresponding angles have to have the same, like, do they both have to be either obtuse, or, like, do they both have to be obtuse, or do they both have to be acute
Yes,
to match up?
corresponding. These will be the same. All of these angles that I've written up here are the same value, right? So A is the same as G as an alternate exterior. A and E are the same value, right? But so A and E are the same value, but A is not the same value as F, right? But corresponding angles are, as long as they're parallel lines,
Okay.
right? Then they have to be parallel. All of this goes out the window if they're not parallel, right? So as long as they're parallel, this is all true. Okay?
Okay.
And then our last one, our consecutive interior. Would you guys agree with me? Interior's in here, right? All right, so consecutive means instead of alternating with the transversal line, right? They're going to stay on the same side as a transversal line. And they're like D and E are called consecutive interior angles. I'm pretty sure that's right. Here I am, I'm doing this lovely lecture, and I just want to be darn sure I'm telling you the right thing. Hang on one second. This is a term I don't use as much, so I just want to be sure I'm saying the right thing. I'm using
Glad
my,
you're not at Yale.
hang on
They
one
would've just
second.
fired you on the
Consecutive,
spot.
I'm right, yeah, I'm right. Consecutive interior. Now, are they equal? Are they equal? Give me an example of two consecutive interior angles. C and what?
C and F. G and F.
C and G are what? Bottom right, bottom right. Those are called corresponding angles, right? But C and F are on the same side. They're both interior, right? They're consecutive interior. They're both inside. They're on the same side of the transversal. Are they the same angle?
No.
No.
No. These are the only ones where, what will they add up to? Do you guys know? 180 degrees. Think about it. If C and F, look, would you agree with me that F and B are the same value?
Mm-hmm.
Corresponding angles? and C is right next to it, right? And it's a straight line. Every straight line has how many degrees in it? 180 degrees.
Really?
So C plus B equals 180. Yeah, have you ever heard the expression, turn in a circle 360 degrees?
Yeah,
I just turned 360 degrees,
yeah.
right? That's half of a straight line.
Wait, so you,
If I, here's my line, boom, that's half of a circle, right? That is 180 degrees. Half of 360 is 180. Boom, that's 360 degrees,
So
right?
a single line has a value of 180 degrees.
Every straight line, whoops, try this again. Please work. Every straight line, right, actually has an angle of 180 degrees. All right? If I cut that in half and I did a 90-degree angle here, right? That would be 90 degrees. You guys know that little square there means 90 degrees?
Yeah.
Well, if this is 90, right? Whoops. 90 degrees right here. What about this? That has to be 90 degrees, right?
Yeah,
What's 90 plus 90?
180.
Right. So I just proved it.
Okay.
So a straight line is 180 degrees, right?
Okay.
So that's really useful information.
I'm feeling really
So we
stupid on
know,
YouTube right now.
so with these first four, right? They are equal, right? What, you know what I mean? The sets are equal, right? You know what I'm saying? Right? I'm not saying the vertical line is equal to the alternate interior necessarily, but I'm saying all vertical angles are equal. All alternate interior angles are equal. All alternate exterior angles are equal. All corresponding angles are equal. But these, how do I do this?
You just draw a line.
Okay, those are add up to what?
180.
Add up to 180 degrees, right? Okay, so that's the difference. Okay, so now, take a picture, Michael. I have my eraser,
Did you
And I am-
finally clean it?
and I am ready to use it, buddy. What?
It's telling me
You told me
to
to duck.
Oh, duck.
Goose.
Say, tell me when you're doing it. Sorry, I'm sorry, I couldn't help it. Did you get it? Did you get it? Oh, no. Did you get a second one?
Can I see it?
Did you get a second one? Okay.
Because it's too late to call the cops. It's too late. I don't even.
Okay,
Trying to be Wonder Public here.
okay, have a seat. All right. So now, on the homework that you have, actually, I think what I'm going to do, well, no, this is a lecture. We'll finish this. Oh my God. Okay, on the homework, it might give you two things. They might say B and F are what? And you would have to just say corresponding angles, right? B and F are corresponding angles, right? So you're going to have to use your notes. Or they'll say A and G. What are they?
They
Alternate exterior angles, right? What are E and D?
Consecutive interior.
Consecutive interior angles. What are A and C? A and C.
Vertical angles.
Vertical angles. There you go. All right. All right. So, then the next part of the homework is going to be like this. It's going to say, this is 60 degrees. Find A.
Oh, I know.
Find A.
Oh, I know what
Okay,
you do.
London, help me.
I know what you do.
London.
It's 100.
Yeah, I know it's 120, but
But how do you know?
because 180 minus 6.
Wait,
Is your
London.
name London? Is it? No.
there are
180
only,
subtract 60.
there are only two angles, right?
180 subtract
Right.
60.
So, 180 subtract 60, right? Why would you say 180 though? Because A is up here and 60.
Because there's different angles.
What is A equivalent to?
E.
E as a corresponding angle, right?
And doesn't
And
equal
so
180.
E plus 60, meaning A plus 60 equals 180.
Yeah.
Subtract 60, you get 120. So A is equal to 120. Does everybody understand that? Make sense? Okay, so then the third section of the homework is more fun, right? And it is going to be something like this. It's going to say find X.
Say
And
what?
It's going to say find X. And
Obviously.
We do D's X.
and I'll give you like something like this.
D's X.
We'll say this is, you know, say 2x plus 10. And then I gotta figure something out here. Like, what do I know about this angle and this angle?
I know how you would do it during.
Okay, Mira.
Or then you would do, since it's 120, you do 2x plus 10 equals 120, and then you would
Right.
minus.
So I could say, see, so we know that this angle is the same as E. This is 120 degrees. Therefore, 2x plus 10, 2x plus 10 equals 120 degrees, right?
Yeah.
Which then we subtract 10, we have 2x is equal to 110, and then divide that by 2, so we got x is equal to 55.
How is that related to
Right.
geometry, though? I know you said that there's some algebra in geometry.
Well, this is the algebra part. This is the algebra part in geometry, where,
But why
where-
would you want 55? though?
Because you need to know how to do that.
because I might have, that's a good question. I don't know, let me think about it. I'm kind of feeling rushed because we're 1 minute over. So, but let me think of it, it's a good question. I think right now, think of it as sort of like just sort of a practice of understanding relationships, right?
Okay.
Understanding the angles and so forth. It is a great question. I know I can give you an answer, I just can't think of an example to answer it right now. So I will try to bring that tomorrow, so you have that. So that's it, that's the
Wait,
lecture.
Comment.